Here is a great prac for observing chemical change. It's from copper to copper. We're going to start with copper and finish with copper. And if we do it just right, we should have the same mass of copper at the end as we do at the start. So we start with about 1.5 gram of copper. I say about 1.5 gram. It is important, of course, to know exactly what you do have. So you would accurately weigh out approximately 1.5 gram of copper. And to this we add 15 mils of 8 molar nitric acid. Now a very obvious reaction occurs as the copper dissolves in the acid. We form NO2, nitrogen dioxide. That's the sort of yellowy brown gas given off. Now you don't want to be breathing this, so of course it's done in the fume hood. And we form copper 2 nitrate solution. That's why the solution is blue. We also form some water on the side as well, but we're not too concerned about that. But the blue solution we get is the copper 2 nitrate. The brownish gas is the nitrogen dioxide. And this reaction is fairly slow, so you do it in a fume hood, yes, but you also then just tend to leave it overnight. And when you come back in the morning, you will find your nice blue copper 2 nitrate solution. And the next step, we take our copper 2 nitrate solution and we add to it 40 mils of 3 molar sodium hydroxide. Now when we do this, we see a bluey sort of gunky, gooey stuff start to form. This is solid copper 2 hydroxide. So the copper has now come out of the solution as copper 2 hydroxide, this sort of gooey substance. Next we add 100 mils of deionized water and then we put it over the Bunsen and we use some heat. And what we notice as we heat it, it gets darker, darker, darker. It in fact turns black. What we've made now is copper 2 oxide. This is a solid. So once we've heated it and stirred it up and heated it, we actually just let it settle and we can see that it does indeed settle to the bottom. That solid copper 2 oxide drops to the bottom of the beaker. Step 4. First we decant off the water from the top. We don't need that. And then we add 50 mils of 3 molar sulfuric acid solution. For some reason I actually forgot to take a photo of my 50 mils of sulfuric acid, but that's right, it just looks like water. It will look like 50 mils of water in much the same way that earlier the nitric acid looked like water and so did the sodium hydroxide. They're all colorless solutions. Anyway, we take that 50 mils of 3 molar sulfuric acid and we add it to our copper 2 oxide solution and we get this lovely blue solution. This is of course copper 2 sulfate solution. The copper is now back in solution as copper 2 ions and that gives the solution the nice blue color. For step 5, we weigh out 5 gram of zinc and we add that. Now remember, we have excess acid in the solution. We've got a copper 2 sulfate solution, but there is also excess acid in there. So when we add the zinc, it will dissolve, it will go into solution, and it will actually displace the copper. So this is a displacement reaction, and we're going to form solid copper in the bottom of the beaker. Now the solution was blue previously because the copper was in solution as copper ions and that gave it the blue color. Once the copper is displaced out of solution, we can see that the solution is no longer blue color because zinc sulfate solution isn't colored. The copper has come out of solution, so the blue color has gone away. We have now a colorless solution of our zinc sulfate and we've got solid copper sitting on the bottom of the beaker. Now all of these 5 steps have been chemical changes. We have been chemically making a new substance. All of those substances had copper as part of their makeup. But this last step, now step 6, we're just going to dry the copper. So we had copper sitting in the bottom of the zinc sulfate solution. We get rid of the zinc sulfate solution, we decant it off. Our copper is now wet, so we put it into an evaporating dish and we heat it over a hot water bath. We don't need to heat it directly over the Bunsen flame. Hot water bath works really nicely, and this will dry our copper, and now we have our final product, copper. Now we started with about 1.5 grams of copper. Remember, it's important to know exactly what you do start with, so you weigh it out. At step 6, prior to tipping the wet copper into the evaporating dish, you would weigh the evaporating dish, and then once your copper is all dry in it, you weigh the dish plus copper, and then knowing the mass of the dish, you subtract that and you have your final mass of copper. Now remember, you don't play God in a chemical reaction. You cannot create or destroy matter. So the fact that you started with 1.5 grams of copper, if you were careful along the way and you didn't lose some from decanting and there were no splashes or anything like that, you should have the same mass of copper at the end. About 1.5 grams, but of course you will know exactly what you do have because you weigh it officially, and that should be pretty much the same mass as what you started with. Well, technically it should be exactly the same mass as what you started with. Some students sometimes say, oh look, I've now got more copper than I started, that's cool. Hey, yeah, no, that's not cool. You don't have more copper than what you started with. You've simply added impurities along the way. Or if they have less copper at the end, some has been lost somewhere along the way. But that last step, that of course wasn't a chemical change, that was just a physical change. You had your wet copper and you turned it into dry copper. So that is that prac, run over a few days. Like I say, that first step, you left it overnight in the fume hood. So it does take a bit of time to get through, but it's well worth it. It's a great prac. So that's observing chemical change from copper to copper. Well, that's the video done. If you liked it, brilliant. Hit the like button and leave me a comment too. Now you know what to do. Go hit that subscribe button. We'll see you next time.